Hello everyone, a very good morning and welcome to my course Basic Physics. This course is generally made for diploma degree students of first year, first semester. Myself, Gopal Chakraborty, Assistant Professor, Department of Physics, Greater Kolkata College of Engineering and Management, Baripur. You can personally meet me at college premises, ground floor physics lab. You can also send me a mail regarding your query and doubt to my given mail address. So that is godphysics6@gmail.com and gopal.chakraborty_gkcem@jisgroup.org. So students, I have a YouTube channel. So the link is given here. You can subscribe my YouTube channel for more videos, as I have already uploaded all the videos as per your State Council syllabus on this subject, Basic Physics. So please go through that video, and if you feel any problem, any doubt, feel free to contact me at my given mail address. So for this subject, I am your subject teacher. Now the course pages are www.webscte.org and www.webscte.co.in. The syllabus is already uploaded in the State Council website. So students, if you want, you can download the syllabus for their first year, first semester curriculum from the State Council website, as the link is given here. So the title of this subject is Basic Physics. It is under the category of Basic Science course. It has a credit 3, 2 lecture per week and 2 practical per week. This course is generally made for diploma degree students of first year, first semester. So all the branches except architecture, photography, multimedia and printing technology, apart from these 4 departmental students, rest of the students have to study this basic physics as a subject for their first year, first semester. So as per our college, we have electrical and electronics and communication department. So these 2 departmental students will have to study this basic physics course in their first year, first semester curriculum. Now today the topic that I will going to be discuss is surface tension, cohesive force and adhesive force, its dimension and SI unit, and also the dimension SI unit of surface tension, surface energy, and example on surface tension, and some numerical. So this is a second chapter of unit 2. So unit 2, which is general properties of matter. So prerequisite for these topics are basic mathematical knowledge to solve the problem, knowledge of basic concept science such as physics, visualization and analytical approach towards the subject is very much necessary. And the course objectives are: analyze the surface tension property of fluids or liquids, reason of surface tension and surface energy with example. After completion of this topic, students will able to know about the surface tension property of liquid, and they can also explain the real life example with it. They will also able to calculate the surface tension and surface energy of a given liquid. So these are basically considered to be as a possible course outcome. Now it's a new chapter, okay? From the general properties of matter, this unit, surface tension is a new chapter, okay? And you will know that why this thing will happen in real life. I will show you some example, but before that, before start describing with the details of this chapter, I want to ask you something. Did you ever see that some insects is just walk on the surface of the liquid, walk through the surface of the water on pond or some rest water? Did you ever see? Yes. Hope some of you have seen this thing. Okay. In some case also you see if you put a stick or matchstick on the surface of the water, it will float. It will never go deep inside the water. It will float on the surface of the water. Okay. But it is not possible for us to walk on the surface of the water or surface of any liquid, isn't it? Now the question is why. I will show you some example. Okay, it will be very helpful or interesting for you. Wait. So I take a matchstick. Okay, it's a toothpick, or you can also take a matchstick. Okay, see, and you just take a normal glass of water, clear glass of water. Okay, now I will put the toothpick on the surface of the water, and I will show you how it will float. It will never go deep inside the water. Wait. Okay, so you can see here, you can check that I just take the water. Okay, is it visible? Oh, okay, so this is the water. Okay, and I just put this stick on it, and you just see it start floating. Okay, hope you will able to see here from that. Okay, it will not go deep through the water, it will float. Okay, interesting. Now came the question that why this thing will happen. Okay, I just put the toothpick on the surface of a glass of water, but it didn't go deep through the water. Okay, it just floating on the surface. How it's possible? It's possible only in that case if you consider that if upper surface is behaved like a net or membrane. That means a single with respect to a single string or like this, a membrane or net can hold a much more weight of any particle. Okay, so basically this thing will happen due to the property surface tension of a liquid. Okay, now I will explain all the things why that insects can easily move through the surface of the water, or why this toothpick didn't go through deep through the water, or why the raindrop on a leaf is showing a circular spherical shape, or why the mercury is also showing a circular spherical shape. Okay, these all things are happening due to that surface tension. So I will now show you how this thing will happen and what is the actual reason behind that. So, surface tension. Surface tension is the tendency of liquid surface to shrink into the minimum surface area possible. So here some example in picture that is shown, that I have already told you that for the insect it is easily possible for them to walk on the surface of a water. But here a clip is floating on the surface of a water, and here the raindrop on the leaf is spherical type. Okay, so surface tension allows insects, usually denser than the water, to float and slide on the water surface. At liquid air interface, surface tension results from the greater attraction of liquid molecules to each other due to the cohesion. I will later describe what is cohesive force and adhesive force. So each other, then to the molecules in the air due to adhesion. The net effect is an inward force at its surface that causes the liquid to behave as if its surface were covered with a stretched elastic membrane. Thus the surface comes under tension from the imbalance force, which is probably where the term surface tension came from. Because of relativity, high attraction of water molecules to each other through a web of hydrogen bond, water has a higher surface tension, that is approximately 72.8 millinewton per meter at 20 degrees C than most other liquid. So surface tension is an important factor in the phenomena of capillarity. Surface tension has the dimension of force per unit length or of energy per unit area. The two are equivalent, but when referring to energy per unit area, it is common to use the term surface energy, which is more general term in the sense that it applies also for the solid. So what is cohesive force and what is adhesive force? It is simply the attractive force between same kind of molecule is called cohesive force, and if the attractive force between different kind of molecules or atoms take place, then it will be called adhesive force. So here for an example you can see here, say if you take a water in a test tube, so the water molecules with surroundings with another water molecule, so the attractive force between the same kind of water molecules is called cohesive force, whereas the water molecules and the stick with some at the edge with the glass tube. Okay, so here the attractive force between the glass surface and the water surface is a example of adhesive force. So I will explain you later why the upper surface is a little bit curved for water or in case of mercury, but this adhesive force and cohesive force plays a very important role for the case of surface tension. So due to this force, the upper surface of a liquid will always behave like a stretched membrane or net to hold the particle or the object on it. Okay, so that's why it can float over that surface of that liquid, and that force is act on a line perpendicular to the tangent of along that placed object. So here this is the example of cohesive force and adhesive force. Now I will explain you the cause as per molecular theory of surface tension. Now, due to the cohesive force, a molecule is pulled equally in every direction by neighboring liquid molecules, resulting in a net force of 0. The molecules at the surface do not have the same molecules on all sides of them and therefore are pulled inward. This creates some internal pressure and forces liquid surface to contract to the minimum area. The balance between the cohesive force of liquid and its adhesion to the material of container determines the degree of wetting. The contact angle and the shape of meniscus. When the cohesion dominates, adhesion energy is less than half of the cohesion energy. The wetting is low and the meniscus is convex at a vertical wall, as for mercury in a glass container. On the other hand, when adhesion dominates, adhesion energy is more than half of cohesion energy. The wetting is high and the similar meniscus is concave as in water in a glass. So surface tension is responsible for the shape of the liquid droplets. Although easily deformed, droplets of water tends to be pulled into a spherical shape by the imbalance in cohesive force of surface layer. In the absence of other forces, drops of vertically all liquids would be approximately spherical. The spherical shape minimizes the necessary wall tension of the surface layer according to Laplace's law. Another way to view surface tension is in terms of energy. A molecule in contact with a neighbor is in a higher state of energy than if it were alone, with some contact with a neighbor. The interior molecules have as many neighbors as they can possibly have, but the boundary molecules are missing neighbors, so compared to interior molecules, and therefore have a higher energy. So for the liquid to minimize its energy states, the number of higher energy boundary molecules must be minimized. The minimized number of boundary molecules results in a minimum surface area. As a result of surface area minimization, a surface will assume the smoothest shape it can. So mathematical proof that the smooth shapes minimize surface area relies on use of Euler-Lorentz equation. Since any curvature in the surface shape results in greater area, a higher energy will also be a result. So this is the cause as per molecular theory of surface tension. Now I will show you some example. These are applications of or examples of surface tension, some phenomena which is actually happen in real life based on surface tension. Okay, so first one that I have already shown you this kind of example, that is needle supported on water surface. So our needle, when placed horizontally on water, floats on the surface of the water. The phenomena is usually justified as surface tension. From what I understand, from the needle to float without sinking, some force has to balance its weight. So since no part of the needle is under the water, buoyant force can be ruled out. So that the force due to the surface tension always acts tangentially to that surface. So this force should not have any vertical component. The needle is below the water level, so actually there is a displaced water and buoyant force. If the membrane where the surface tension is located is in equilibrium, it needs to receive an upward force. So here the figure is there. The upward force is the buoyant force due to the displaced water that is shown here. So this actually happens due to the phenomena of surface tension. Second one, I have already told you regarding the why the surface tension enables insects to walk on the surface. So water molecules as strongly attach onto one another. This is due to the strong hydrogen bonding. Proton in water is shared between the two oxygen atom of two water molecules. So considering only the water and air, minimizing the interface surface area is the lowest energy states, because it's allow for maximum interaction between water molecules. So if the water molecules were attracted to the molecules of the insect leg and weighted them, the legs would sink into the liquid. However, in the context of the legs not being weighted, so the attractive force of the water molecules results in a net upward force on the legs of the insects as the legs deform the surface. So this is the actual cause of surface tension, by which the water can easily walk or float on the surface of the water or any liquid. Some examples is also there, that is raindrop are spherical in shape, drops of mercury spherical in shape. Okay, raindrop starts to form in a roughly spherical structure due to the surface tension of water. This surface tension is the skin of a body of water that makes the molecules stick together. The cause is the weak hydrogen bond that occur between water molecules. Why the drop of mercury is spherical in shape? Due to the surface tension, mercury tries to acquire the minimum surface area, which is a minimum for sphere. For small drop, gravity effect is small and mercury drops are nearly spherical. As the size of the drop increase, force of gravity on the drop increase, which tries to deform the shape. The hairs of a paintbrush cling together when taken out of the water. So when the brush is removed from water, hair of the brush cling together as the water that gets attached to the hair tries to minimize its surface area in order to reduce the residual force, thus creating tension known as surface tension. So surface tension is the actual cause for which a paintbrush cling together when taken out of the water. So these are the possible examples that you may deal with in daily life, or you already many of you have seen these things will happen. Okay, but so this is the actual cause behind this. Next one, that is surface energy. So what is surface energy? The free surface of a liquid possesses minimum area due to the surface tension. To increase the surface area, molecules have to be brought from interior to the surface. Work has to be done against the force of attraction. So this work is stored as the potential energy of the molecules on the surface. So the molecules at the surface have extra energy compared to the molecules in the interior. So the extra energy possessed by the molecules of surface film of the unit area compared to the molecules in the interior is called surface energy. It is equal to the work done in increasing the area of the surface film by a unit amount. So surface energy can be mathematically written as surface energy is the work done per increase in surface area. So it has a units as energy is joule per meter square. Now the relation between surface energy and surface tension. So how we will find out the relation? So consider a rectangular frame ABCD. I have shown you here, in which the wire AB is movable. Okay, dip the frame in soap solution. Flame is formed which pulls the wire AB inward due to the surface tension with the force F equals to 2 sigma into L. So here the factor 2 is taken because the soap flame has two free surfaces. Okay, you can see the diagram is here. So suppose AB is moved out through the distance x to the position A dash B dash. Okay, previously the position was AB. Now if you pulled it, now the final position will be A dash B dash. So the distance it will cover, that is x. Okay, so what is the work done? So the actual work done is force into distance. So it is 2 sigma L into x. Okay, so increase in surface area of the flame. What is the area? So it is 2L, the true length, and into the displacement, so 2L into x. So what is the surface energy? Work done per increase in surface area, that is surface energy. So what is the work done? That is 2 sigma L into x. And what is the increase in surface area? That is 2L into x. So 2 cancel out, L cancel out, x cancel out. Ultimately we will get surface energy, that's equals to sigma. So the surface energy of a liquid is mathematically equals to the surface tension. So now we will solve some numerical on this topic that today I have discussed. So it will be very clear for you. First problem, calculate the work done in blowing a soap bubble from a radius of 2 cm to 3 cm. The surface tension of the soap solution is 30 dyne per centimeter. So here initial R1 radius 2, final radius is 3, and sigma that is given, that is 30 dyne per centimeter surface tension. So what is the increase in surface area? So it is 2 into 4 pi into change in radius square. So 2 into 4 pi into R2 square minus R1 square, so 8 pi into 3 square minus 2 square, that means 40 pi centimeter square. So what is the work done? Work done is a surface tension into increase in surface area, that is 30 into 40 into 3.142. It means 3770.4 arc. Second one, the surface tension of a soap solution is 0.03 Newton per meter. How much work is done to produce a soap bubble of radius 0.05 meter? So it's a direct problem. You can write the work done is equals to total surface area into surface tension, and if you substitute the value, you will get 1.884 into 10 to the power minus 3 joule. Second one, if 50 arc of work done in blowing a soap bubble of radius r, what additional work is required to be done to blow it to a radius equal to 3r? So the initial radius was r, final will be 3r. So work done in blowing a soap bubble from radius 0 to r is work done can be written as surface tension into 2 into 4 pi r square. So additional work required to increase the radius from r to 3r will be then sigma into 2 into 4 pi within bracket 3r whole square minus r square. So it will be sigma into 2 into 4 pi into 8r square, that is the w dash, new work done, additional work done. So dividing these two, additional work done with the initial work done, w dash by w, that value is equals to 8. So w dash equals to 8 into w. So initial work done is 500 arc, so final work done, extra amount of work done needed is 8 into 500 arc, that is 4000 arc. Next problem, soapy water drips from a capillary tip. When the drops breaks away, the diameter of its neck is 1 millimeter. The mass of the drop is 0.0129 gram. Find out the surface tension of soapy water. So when the drop breaks away from the capillary, weight of the drop, that's equals to force of surface tension acting on the capillary. So you can write that force, that means weight, the mg, that's equals to pi into capital D, where D is the diameter, into surface tension. So surface tension equals to mg weight by pi into diameter. So if you substitute all these values, that will give you 1.29 into 10 to the power minus 5 into 9.8 whole divided by 3.14 into 1 into 10 to the power minus 3. So you will get the surface tension is 4.03 into 10 to the power minus 2 Newton per meter. So this is your answer. Now these are the possible books that you can refer for your this course, this topic. Evaluation process is the same. You have to appear for a 70 marks end semester exam, 20 marks mid semester exam, and 10 marks for attendance, assignment or interaction. So today this is the first class on this chapter surface tension that I have discussed. So all of you have enjoyed and understand. In next class I will discuss the rest part of the chapter surface tension. So thank you.